Today we are going to prove that the path of a projectile is parabola. Before going to this derivation, let me give you some important points that is useful for this derivation. First of all, what is projectile? Any body projected into air at an angle other than 90 degrees with the horizontal near the surface of the earth is called as projectile. That means on the surface of the earth, if you throw any object with an angle other than 90 degrees, then we'll call that object as projectile. Let us see some examples for projectile. The first example is a bullet fired from a gun. Okay, now see, this is a bullet. Now I am firing this is a gun. Now I am firing a bullet from the gun. Okay, now what will happen? This gun will exert a force on this bullet in this direction. Because of this, what will happen? This bullet will start moving along this direction. Now what happens? After some time, this bullet will changes its path. Why does it change its path? Because this change in path is because of the gravity which is acting in vertical downward direction. Because of this vertical downward force, this bullet, instead of moving in straight path, it moves in a curved path. Okay. Next, the other example is a cricket ball thrown by a fielder. Next thing is a javelin thrown by an athlete. A jet of water from a rubber tube. So all these are the examples for projectile motion, where the projectile, that is the body, will move in a curved path. Okay, and the reason for the body to move in curved path instead of going in a straight line is because of the vertical downward force, which is nothing but the force due to acceleration due to gravity. Okay, next, the other points that are useful for this derivation is, if in any motion, if speed is constant, then the only formula that we can use is speed is equal to distance by time, or distance is equal to speed into time. Okay, speed is constant, that means acceleration is 0. So though we use these equations of motion, these equations of motion will get converted into distance is equal to speed into time. That what I mean is, if you use s is equal to ut plus half at square, and if you substitute a is equal to 0 in that equation, you will get the equation distance is equal to speed into time. Okay, the next point is, if speed is not constant, that is if the body is moving with some acceleration, then we can use all the equations of motion. Okay, so all these points are useful for our derivation. Now let us come to our derivation. The derivation is, the derivation to prove that the path of a projectile is parabola. Okay. Now let me assume that I throw a projectile with a velocity u, making an angle phi with the horizontal. The velocity can be resolved into two components, that is u cos theta along u cos phi along horizontal direction, u sin phi along vertical direction. After time t, let p be the position of the projectile. Okay, the coordinates of this point is x comma y. Okay, next, now this is a two-dimensional motion. Why do I say that this is a two-dimensional motion? Because as the projectile moves, the horizontal the x component will change and y component will change. So since this is a two-dimensional motion, this can be treated as two different one-dimensional motions, one along horizontal direction and other along vertical direction, and the changes along horizontal direction and vertical direction takes place independently. Okay, now let us see along the horizontal direction. Along the horizontal direction, the initial component of velocity, that is horizontal component of velocity, is u cos phi. Since there is no horizontal force acting along the horizontal direction, the horizontal component of velocity will remain constant. Now the only formula that we can use is distance is equal to speed into time. That is x, which is nothing but the horizontal position of the particle after a time t. X can be written as u cos phi into t, or t can be written as x by u cos phi, where t is the time taken by the projectile to reach the point P from O. Okay, now let us go along the other direction, that is vertical direction. Along the vertical direction, the initial velocity is u is equal to u sin phi. Now along this vertical direction, the force that is acting on this projectile is gravity, which is in vertically downward direction. Because of this gravity, what will happen? The projectile which started at O will move from 0 to A. As the projectile moves from 0 to A, the vertical component of velocity will decrease. As the particle moves from 0 to A, the vertical component of velocity will decrease and reaches to a point where the vertical component of velocity is constant. Okay, that point we'll call it as maximum height point, and that distance and the distance of this point from our horizontal is called as maximum height. After maximum height, what will happen? Because of the vertical downward force, the vertical component of velocity will increase and slowly the projectile will come down and hit the horizontal at some point with a velocity u, which is nothing but the initial velocity of projection. Okay, and that point is called, that point will treat it as b. Okay, so and this distance from o to b will call it as range, and this maximum height will call it as maximum height will call it as h. To know more about range and maximum height, click on the link given in the description. Now let us go to our vertical motion. Along vertical direction, the initial velocity is u sin phi, and this projectile is being subjected to an acceleration a is equal to g, which is in downward direction. That is a is equal to minus g. And let t be the time taken by the projectile to reach the point P from O. Okay, and let y be its vertical displacement. Now, if you apply the formula s is equal to ud plus half at square, you will get y s, which is nothing but y is equal to initial velocity u sin phi into t minus half gt square. Okay, from here we know that the expression for time is t is equal to x by u cos phi. Now, if I substitute this time in this formula, then I will get y is equal to u sin phi into x by u cos phi minus half g into t square, that is x by u cos phi whole square. Okay, then y is equal to u sin phi into x by u cos phi minus half g into x by u cos phi whole square. Okay, now this u and this u will get cancelled, then sin phi by cos phi will become tan phi, that is y is equal to x tan phi minus, if I arrange all these, what will I get? Minus g by 2u square cos square phi into x square. Okay, so this is the final equation, that is y is equal to x tan phi minus g by 2u square cos square phi into x square. If you observe, this equation is of the form y is equal to ax minus bx square, which represents the general equation of parabola. Okay, where a is tan phi and b is g by 2u square cos square phi. So finally we proved that the path of this projectile represents the form y is equal to ax minus bx square. Hence we can say that the path of a projectile is a parabola. In our derivation, we assume that phi is the angle made by the velocity vector with the horizontal. If we take phi as the angle made by the velocity vector with the vertical, then the formula for time will be time taken by the projectile to reach the point P will be t is equal to x by u sin phi, and the general equation of parabola will be y is equal to x cot phi minus g by 2u square sin square phi into x square. Okay, that is one point. Next point is, this entire derivation will be valid when the value of phi is between 0 to 90 degrees, that is excluding 90 degrees. Okay, next, the other point is, in the entire derivation we didn't take air resistance into consideration. What do you mean by air resistance? Let me say one example for this. When we go on bike on road, what will happen? This air will oppose our movement. Okay, this opposition created by air on a body is called as air resistance, and this opposing force depends upon the velocity. That is, more is the velocity of the body, more will be the opposing force, that is more will be the air resistance. Okay, that is one point. Now if we come to our example, if we come to our present case, this projectile is moving in a medium which is nothing but air medium. So, and this projectile is moving with some velocity, that means this air will oppose the motion of this projectile. Okay, so this opposition will call it as air resistance. Since we didn't take this air resistance into consideration, so we took that the horizontal component of velocity is constant. But if we consider this air resistance, or if we take this into consideration, the horizontal component of velocity will not be constant. Then we can't use x is equal to u cos phi into t. Okay. Similarly, in vertical direction, we took that acceleration a is equal to minus g, assuming that there is no air resistance. But if you take air resistance into consideration, then the value of acceleration will be a is equal to g minus of some factor. That some factor is because of air resistance. If you feel that this video is useful, Kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Do like and subscribe because your single like and comment will encourage me for making better videos. Thank you.